All right, so we're back and ready to dive right back into these LLMs. Last time we were talking about those transformer networks.
Oh, yeah, those are pretty cool.
And that whole attention thing, it's like a light bulb moment letting these models process so much more information than ever before. Like they can see the connections across tons of text at once.
Exactly. It's almost like they can grasp the whole story, not just get hung up on individual words. Like, finally, they get the context.
Right. But today we're going to talk about, how we go from that blank slate transformer to something as powerful as, say, ChatGPT, the training process, turning that raw potential into a language whiz.
Right. And you've picked a good time to just talk it through because actually training a full-blown LLM, that's a supercomputer level task, not something you'd whip up on your laptop.
Oh yeah, not exactly a weekend project. But the cool part is, even if we're not building a ChatGPT rival today, just understanding how it's done is incredibly valuable. It's the key to building your own smaller, more targeted LLM-powered applications.
Absolutely. And the training process isn't just one big blob. It's actually two distinct stages, pre-training and fine-tuning.
Okay, 2 stages. Break it down for me. I'm all ears.
All right, so imagine you're teaching a kid language for the first time. You'd surround them with books, conversations, all kinds of text, right?
Sure, yeah, immersion, right?
Exactly. They soak up grammar, vocabulary, the basic rules, without even realizing it.
It just comes naturally over time.
And that's pre-training for an LLM massive exposure to unlabeled data. We're talking terabytes.
Wow, terabytes. That's a lot of data. So what kind of data are we talking about? I see Common Crawl in the sources, a data set of, wait for it, web pages.
Yep, the whole internet, pretty much. Plus all of Wikipedia, books, even code. They throw the whole digital world at these things.
They throw the whole internet at these things. So the goal of pre-training isn't to master specific skills, it's to get that foundational understanding of language itself.
Exactly. It's about the underlying mechanics, the how language actually works.
How does it work?
Through this incredibly simple yet computationally intense process called next token prediction.
Ooh, next token prediction. Now this is where it gets juicy. So the model's constantly playing this guessing game. What word comes next? And by doing that billions of times on all that crazy data.
It starts picking up the patterns of language, not just isolated words, but how ideas flow, how facts connect. It's like they develop a sense of logic almost.
Wow. Okay, I'm starting to get it. But how does the model know if it's guessing right?
Ah, great question. That's where the loss function comes in. Think of the loss function like a coach yelling at you for a bad golf swing.
Okay, I like this analogy. So the worse your swing, meaning the worse the model's prediction.
The louder the yelling, right, the higher the loss. We want to keep that coach happy, so we got to lower that loss by making better predictions. In this case, the loss function is cross entropy, measuring how far off the model's guess is from the actual next word.
So the model is constantly trying to improve its golf swing, to quiet down that coach as it devours all this data.
Precisely. And it does this by tweaking its internal parameters. Remember those billions of knobs we talked about in the Transformer episode?
Oh yeah, the knobs, those tiny little adjustments.
Right. Each knob controls some aspect of the model's behavior. And to help with all that tweaking, we have the optimizer.
Okay, so the optimizer is like the model's personal trainer.
Haha, yeah, exactly. It helps the model get in shape to make those killer predictions. Adam W is a popular optimizer known for being, efficient and robust. It's like choosing the right workout routine to get your AI in peak condition.
So we've got our data buffet, the prediction game, the loss function as our grumpy coach, and the optimizer as the encouraging personal trainer. What about the learning rate?
Ah, yes, that's like how intensely the model is training, right? If the learning rate is too high, it's like sprinting through a marathon, you might burn out quickly. Too low and you're barely moving, finding the right pace is crucial.
And like any good workout, we don't just stick to one pace the whole time, right? We need a plan. Enter the learning rate schedule.
Exactly. The learning rate schedule changes the pace over time, usually starting faster and slowing down as the model gets better. Think of it as warming up, pushing hard in the middle, then cooling down to avoid overexertion.
Makes total sense. And we can't forget about batch size, right? That's like how much data the model gobbles up at once.
Right, and this is where those powerful GPUs and TPUs come in. Processing huge batches of data simultaneously is like having a team of chefs prepping ingredients for a massive feast.
I love it. The bigger the batch, the faster the training, but you need the right kitchen equipment to handle it. So data, predictions, loss, optimizers, learning rates, batch sizes, we're cooking with gas here. But what about overfitting? Isn't there a risk the model just memorizes the training data?
That's a great point. It's where regularization techniques come into play. These are like study strategies that force the model to learn more generally. One example is dropout.
Dropout. Does that mean the model just randomly forgets stuff?
Sort of. Imagine you're studying for an exam, right?
Yeah, I remember those days.
If you only focus on a few key topics, you might ace the test, but you won't truly understand the subject. Dropout is like forcing yourself to study different parts of the material randomly.
So it's like making sure our student can handle any question on the exam, not just the ones they memorize. Okay, now this has all been about pre-training, that broad language immersion. What about stage two, the fine-tuning?
Well, if we think about the big picture,
Is this where we go from surrounding our language student with books to actually teaching them how to write specific types of essays?
precisely. With fine-tuning, we take that general language whiz and give it specific skills. We start using smaller, labeled datasets, tailored to the task we want the model to perform. One approach is supervised fine-tuning, or SFT.
So with SFT, we're giving the model input-output pairs, right? Like, here's a question, here's the answer, here's a topic, here's a summary. The model learns by example.
You got it. And there's another cool approach called instruction tuning, or IFT, where we teach the model to follow instructions. This is what makes chatbots so versatile, right?
Oh yeah, like you can say translate this or summarize that, and they actually do it.
Exactly. It's like giving our student a set of tools and showing them how to use each one.
Wow. So pre-training builds the language engine, and fine-tuning customizes it for specific tasks.
A perfect way to put it. And all of this might seem like a lot of jargon, but even if you're not planning on training your own LLM from scratch,
Understanding this two-stage process is super valuable.
right, it helps you make smarter choices about which models to use for your own projects and how to fine-tune them for maximum impact.
This is great. All right, everyone, we've covered a lot of ground today. It's a lot to take in, so let's take a quick break. We'll be back in a bit to talk more about the resources needed for all of this and what it means for you. Stay with us. Welcome back, everyone. My brain is like still buzzing from all that talk about pre-training and fine-tuning. It's amazing how we can teach machines to, use language like that.
It really is remarkable, and it brings us to an important point, something we touched on earlier, the sheer scale of resources needed to train these LLMs.
Yeah, we're not just talking about needing a fancy laptop here.
Not even close.
These models have like billions, sometimes even trillions of parameters, and they're trained on data sets that could fill entire libraries.
Exactly. It's like building a skyscraper. You need massive amounts of materials, a whole team of specialized workers.
Right, the right tools for the job.
For LLMs, the materials are those huge data sets, and the workers are specialized hardware, like GPUs and TPUs.
GPUs and TPUs, those are those super-powered computer chips, designs for handling these kinds of complex calculations, right?
Yep, and you often need hundreds, even thousands of them, all working together for weeks or even months to train a single LLM.
So when we say LLM training is resource intensive, we really mean it. It's a huge undertaking. It makes you realize why not everyone is building their own ChatGPT from scratch.
Exactly. And this realization is actually incredibly valuable for you, even if you're not planning to build the next big language model.
How so?
Because it highlights the power of leveraging pre-trained models. Think of it this way. You don't need to build a car from scratch to drive it, right?
Right, someone else has already done all the hard work.
Exactly. Someone else has already done the heavy lifting, designing the engine, the chassis, all the complex parts.
Ah, I see where you're going with this. So instead of building our own LLM from the ground up, we could tap into the power of these already existing models, the ones that have been trained on those massive data sets.
Precisely. These pre-trained models are like cars that are ready to roll off the lot. You can choose the make and model that best suits your needs, and then
We can fine-tune them. We can take that powerful base model and customize it for our specific purpose.
exactly. Just like you might add some custom features to a car, like a spoiler or a VC sound system, you can fine-tune a pre-trained LLM to perform specific tasks or work with specific types of data.
So instead of needing those massive computing resources and terabytes of data, we can leverage the work that's already been done and focus on fine-tuning a model for our own needs.
Exactly. And that's where understanding the fine-tuning process becomes even more valuable. We talked about supervised fine-tuning and instruction tuning earlier. Knowing how these techniques work and how to apply them effectively is key to unlocking the power of pre-trained models.
It's like having the keys to a high-performance car. But before we go racing off into the sunset, let's take a step back and recap all the amazing things we've learned about LLM training today.
Right. We started by understanding that training happens in two main stages. Pre-training, where the model learns general language abilities from a massive unlabeled dataset, and fine-tuning, where we adapt that model for specific tasks using smaller labeled datasets.
And within those two stages, there's this whole intricate dance of components. The loss function guiding the model's learning, the optimizer helping it tweak those billions of parameters, the learning rate and batch size influencing how the model learns, and regularization techniques, preventing it from just memorizing the training data.
All of this comes together to create these incredibly powerful language models that can generate human quality text, translate languages, write different kinds of creative content, and answer your questions in a way that feels almost human.
It really is mind-blowing. And now, understanding that this whole process is so resource-intensive.
It makes us appreciate the power of leveraging pre-trained models. We don't need to start from scratch to build something amazing.
So even if you're not planning on building the next ChatGPT,
Knowing how LLMs are trained, from the vast scale of pre-training to the intricacies of fine-tuning, gives you a huge advantage. It's like having a roadmap to navigate this exciting world of artificial intelligence.
it helps you make informed decisions about which models to use, how to fine-tune them effectively, and how to build applications that truly push the boundaries of what's possible.
And speaking of pushing boundaries, before we wrap up this part of our deep dive,
We have a question from Emily in London. She's curious about how to tell if a model is overfitting and what to do about it. It's a great question, Emily, because as we talked about earlier, overfitting is like a student who can ace a test by memorizing answers, but doesn't actually understand the material. So how do we spot these memorizers in the LLM world?
well, one of the key signs is a big difference in performance between the training data and a separate validation set.
A validation set, that's like a practice test that the model hasn't seen before, right?
Exactly. It's a way to see how well the model generalizes to new information. If the performance on the training data is much higher than on the validation set, that's a red flag for overfitting. It means the model might be getting too good at remembering the specific examples it's seen, but not learning the underlying patterns of language.
So if we see that red flag waving, what can we do about it?
There are a few things we can try. Remember those regularization techniques we talked about early, like dropout? They can help prevent overfitting by forcing the model to learn more generally. We can also experiment with using a smaller model with fewer parameters. Sometimes a simpler model can be less prone to overfitting. And of course, if it's feasible, getting more data to train on can often be the best solution.
It's like giving our student more practice problems so they can't just rely on memorization.
Exactly. And finding the right balance between memorization and generalization is often a matter of careful experimentation and fine-tuning.
Well, folks, we've covered a lot of ground in this part of our deep dive, from the massive resources needed for training to the power of leveraging pre-trained models, and even some tips on how to spot and address overfitting.
We're starting to see just how accessible this incredible technology can be.
But we're not done yet. In our final segment, we'll explore even more practical ways you can harness the power of LLMs, even without a supercomputer at your disposal. Welcome back to the deep dive. Ready for the final lap of our LLM training journey.
Absolutely. We've explored pre-training, the fine-tuning toolkit, and even that whole resource-intensive nature of building these massive language models.
And now, for the grand finale, we want to leave you with the most empowering takeaway from all of this.
Well, the idea of, training a ChatGPT competitor from scratch might seem daunting. Remember, most of us won't need to do that. The real magic is understanding how to leverage pre-trained models.
Right, like we've been given this incredible toolbox, right? Filled with powerful language models already trained on those massive datasets.
Think of it like walking into a well-stocked kitchen. You don't need to grow your own vegetables or grind your own flour. The ingredients are all there, ready to be used.
So instead of building a language model from scratch, we can focus on, selecting the right pre-trained model and customizing it for our needs.
Precisely. And that's where the fine-tuning process we discussed earlier comes in. By carefully selecting a model that's already, good at what we want it to do, and then fine-tuning it with a targeted data set.
We can create some incredibly powerful AI tools without needing, those supercomputers and mountains of data.
It's like taking a high-performance sports car and adding some custom features for off-road racing or a luxurious city drive. The core engine is there. You're just adapting it to your purpose.
This is what makes this technology so exciting. It's not just for, big tech companies with tons of resources. Anyone can harness the power of LLMs.
Exactly. And as you explore the world of pre-trained models, you'll find they're designed for an incredible range of tasks, from translation and summarization to code generation, creative writing, and so much more.
The possibilities are truly mind-boggling. I can imagine, like personalized learning assistants, AI-powered tools for scientific discovery, even new forms of storytelling.
The only limit is your imagination. And as you dive into building your own LLM-powered applications, remember the key takeaways from our deep dive today.
Understand those two stages of training, pre-training and fine-tuning. Familiarize yourself with those key components, like the loss function, optimizer, learning rate, and batch size.
And don't forget those regularization techniques. To avoid overfitting, think of them as your AI's study strategies for success.
And above all, don't be intimidated by the complexity of LLM training.
Leveraging pre-trained models puts this amazing power at your fingertips. Explore, experiment, and have fun. The world of AI is waiting to be discovered.
That's it for our deep dive into training large language models. We hope you've enjoyed the journey and feel inspired to start building your own AI-powered applications.
Until next time, keep learning, keep questioning, and keep exploring this incredible world of artificial intelligence.
This is the Deep Dive, signing off.